Right, part B. Draw and label arrows on the diagram below showing all the forces acting on Willow and her bike when accelerating. Okay, so this isn't actually the picture that was in the paper. For some reason, they just pull them when they print them up onto their website, but you probably can find it here. I don't know, it's nothing due to copyright, but I've just put this one in. It's basically a similar idea. She's facing in the same direction. And so it was just normally a woman on a bike. Okay, so when it says draw and label all of the forces, this means we're going up, down, side to side. So all of them, not just the horizontal or the vertical. Okay, so we know that the vertical forces, so the up down forces, are going to be equal and opposite because she obviously isn't falling down or like rising up out of off the ground. Ignore what's happening in this picture. So these are going to be the same size, just to indicate that they're equal and opposite. Okay, so that is the down, and it's fine. Just another thing to do them in that direction or to do it this way. That's fine. Either way is fine. Just as long as they're opposite. Okay, so the up force would be our support force. Sometimes it's called the reaction force. And I've also seen it called normal as well. Probably the support and reaction are the most common ones. And then the down force is the weight force. And it is due to gravity, so it is acceptable to write gravity as well there. So then we've got our side-to-side forces. So we know that she is accelerating forward. So net force is not equal to 0. It's not balanced. So we're going to have one that's bigger. So the forward force is going to be bigger than the back force. The forward force, the acceleration is called thrust. And the back force is friction or resistance of some sort. And that's the forces there. So that's worth an achieve to get those correct. But it is sort of in conjunction with this next part of the question. So explain the sizes of the force involved when Willow and her bike are accelerating. So first of all, talk about the up-down forces. So the vertical forces are balanced. So her weight force is equal to the normal force. So vertical net force is equal to 0, something along those lines. So equal and opposite. Maybe say that too. Equal and opposite. Okay, so the horizontal forces are unbalanced. And so therefore, what's her name? Willow. Willow is accelerating to the left as thrust is larger than friction. So net force is not equal to 0 in this instance, and the bike will accelerate to the left, something along those lines. Okay, so this is an excellent answer for all of these things. So for all of these things, you need to have a correctly drawn diagram and explain that the unbalanced forces cause this change of speed. So, it's unbalanced, and so therefore she is accelerating. And then you also so you need to sort of talk about those things. And then you also need to have the direction of that. So to the left. So these 3 things are needed for the excellence. There's loads of marks that you can get for achieved and merit as well, but obviously we're all aiming to get the best. So good diagram, equal and opposite, unbalanced, therefore accelerating, and the direction of the acceleration.